What looks like the machining of a perfectly ordinary piston is in fact a true feat of engineering and an example of pioneering work. This piston was produced using 3D printing technology. 6 of these components were tested in Porsche's most powerful 911, the GT2 RS, and it's Mahle that made it possible. Additive manufacturing is very important to Mahle. It allows us to supply components to our customers more quickly and on a flexible and agile basis, which means we can reduce development time. This applies to the conventional components we have today and serves as a bridge to new forms of mobility, to e-mobility, because that will involve large numbers of small lots. A major advantage of this process is the possibility of realizing a new type of bionic architecture, drawing inspiration from structures in the natural world. Material is only used in areas that are subject to forces. This concept opens up previously undreamed of opportunities for engineers. We're able to make the best use of installation spaces and develop designs that cannot be manufactured by conventional means. This allows us to construct items bionically, so to speak, and produce extremely lightweight yet high-strength components, which are now helping us to cut out a huge amount of weight in the case of our piston design. As a result, we can run the engine at a higher RPM and thus generate more power. The new manufacturing possibilities mean that a cooling gallery can also be incorporated into the piston, which reduces the temperature in the areas of the piston that are under the greatest load. This increases the efficiency of the engine. Mahle has more than 100 years of experience in the development and manufacture of pistons. The new production process is based on an aluminium powder made of a special alloy. This was developed in-house by Mahle and has been used successfully for a long time. Project partner and laser specialist Trumpf creates the piston blanks from 1200 layers in a 12-hour printing process. Before being fitted in an engine, a 3D printed piston undergoes the same steps as a conventionally manufactured piston: machining, measuring and testing. Mahle's engineers pay particular attention to the outer shell of the piston, known as the skirt, and the point at which it connects with the conrod, also called the pin bore. At this point, the additively manufactured piston has undergone the usual laboratory tests, including a pulsation test and a tear-off test. The pulsation test is used to check the thickness of the skirt wall and the skirt to ensure no cracks develop. The tear-off test makes sure that the pin bore will not shear. The results are in. All the pistons have passed the test. Next, it's on to the bench test, a 200-hour endurance test under the toughest conditions. This involves around 135 hours under full load and 25 hours under motored load. The positive results confirm the great potential of 3D printing, especially for high-performance, small and limited runs, and when it comes to prototyping. If I keep working on it, I can manufacture all the spare parts the aftermarket needs. I could even take an on-demand approach. In other words, a customer sends me a drawing and I can make the parts without needing to keep tools or parts in stock. The 3D printed piston is just the beginning for Mahle. The technology group is further developing its expertise in 3D printing to meet its customers' needs, especially in the field of alternative drives. Mahle is thereby cutting short the journey from concept to prototype, enabling the rapid production of small lots and accelerating the process of designing and testing new technologies. In doing so, Mahle today is making its contribution to the mobility of tomorrow.